Okay, propane versus wood heat in the Arctic oven. What I've learned to date, I think maybe I've given out some bad information, so I'm going to correct it. When it gets to be minus 40, the propane has trouble getting out of the liquid state. Welcome to the Yukon in North 61. So, we learned a little bit more about my propane, which I just was so high on because it's so clean and handy. But when it gets really cold, strange things start to happen. And I'm not exactly sure where the transition area is. It seemed like on this trip, about minus 30, we started to lose a significant amount of heating. So sometimes when you need the heat the most, you start losing pressure in your tank. And although you can find different ways to heat the tank, we were thinking about putting the exhaust from our machines, which we have to start every 2 hours. We thought of chemical hand packs, but whatever you think about, it's just minus 40 is really the cutoff. And even before minus 40, you start losing pressure. Even in a bigger tank. Like I thought maybe a bigger tank would help, and as we can see in a bit, it will help, but only to a certain point. So propane is a great, I'm thinking minus 30, minus 28 centigrade, which is around minus 20 Fahrenheit, is sort of the cutoff for propane for a portable tank. The amount of pressure that a tank can put out at minus 30 is 6.8 pounds per square inch. The regulator is set at 10 or 12, so you're not even getting all. That's with even a full tank, you're not getting all the pressure that even the regulator can give. And if you're up to 20 degrees, it's 42 pounds per square inch. So that's why you need the regulator, but you're not getting all the fuel you need for even these low pressure devices. And it also, there's something that happens when the cylinders become 25% full, say. So at 25% full, at minus 20, a 20 pounder is only giving you enough vaporization to give you 2,050 BTUs per hour, which is about what we were finding when our tank got low. Which is one of the advantages of having a bigger tank. A 40-pound tank, 25% full, would still give you 3,400 BTUs at minus 20, which is again minus 30 centigrade. But you really do lose a lot of the necessary power to run your device at full power. Now, if that tank was full, you'd probably get 4 times that, so 8,000 BTUs per 20-pounder, or maybe even a little bit more, which would probably almost be enough to keep you warm. But it's not going to stay full unless you bring 2 tanks. So for me, I'm going to play with it a little bit more, but I really think about minus 20 Fahrenheit, minus 30 centigrade is a time where you're much better off probably with wood heat. Problems with wood heat is it's an uneven heat. With the size of stove box that you get in an Arctic oven, you're not going to have a very, very steady heat. You're going to have highs and lows, but my God, it's better to have some highs rather than all low. And it's also really important to be able to melt water. We were having difficulty melting water with that stove. We needed to bring auxiliary stoves. When you have to bring auxiliary stuff, well, why not have something that's totally reliable, which is wood heat? So I think I'm going to probably about minus 20 Fahrenheit is going to be my cutoff. If it's likely to get below minus 20 Fahrenheit, I'm probably going to bring the wood stove.
So it's 2:33. We've got some coal started, and we're just going to see down how long those coals are going to go for. I'll maybe just put one more new stick in.
So basically, what is the temperature curve like with a 12 by 12 by 24 stove, which is something like that Nyko or something that I would build for a tent? Basically, you got about a 2-hour heat wave, and you get really hot, and then it goes down, and then it might have a little bit of a raise. There's a little bit of a when it gets anaerobic and all the coal, sometimes you get a little more heat and then it'll slowly die to almost nothing. It'll take about 2 hours. Then 2 hours later, you put more sticks in, and then you got to take your covers off because it's going to get really hot for a while. But in the meantime, the water melting or the snow is melting, your clothes are getting dry, you're getting hot, and then it's slowly going to get colder. So you've got these hot and cold waves. It's not as comfortable as the propane, but past about minus 20 Fahrenheit, I think it's probably the only way to go. If it's above minus 20 Fahrenheit, I just find it's too hot for that insulated tent. So I think the propane and the wood heat kind of work together. And I guess if you were out in all of those conditions, you'd probably go with wood heat and just put up with the inconvenience. The propane is really, really handy springtime when it's not super cold, early winter, or in the heat waves in the winter. We're having more and more of those. And if you can have higher temperatures, the propane gives you nice even heat all night. It's hard to beat. It's just like living at home. So I think both of them actually have a place.